Welcome. In this video I talk about JSON in Rust. Why do I do JSON? Well, first of all, I like it, and secondly, I like the really well done integration of JSON features into Rust. Let's see. To begin with, all I have to do is to put two dependencies in here, namely the one is serde, and I add the feature derive, and serde JSON. Serde is a general serialization, deserialization framework, and it's quite powerful, and you will see it in action in a second. As first example, I show you how you can just use JSON data in Rust. There's a JSON exclamation mark macro, and in round brackets you can just put any odd JSON, and the value j will represent that faithfully. So that's a value, and a value is actually an enum with a typical JSON possibility. So there's null, there's a bool, a number. So that's not right data type, faithfully representing JSON. Now, what can we do with things like that, with such values? We can print them. There's a print support. We can convert them to string, knowing that the result is UTF-8. And we can access sub-items here. For example, this is an object, and it has an E attribute, and I can act with the square bracket and E here. And notice that I then should take the reference here, because A will here be a reference to value, and that will directly reference the sub-data in the tree here. Here I have put all the different data types which are there in JSON. The JSON macro also allows you to put a vector in there, which will be represented as an array. And it allows you to put a hash map in there, and you can easily print things. So let's run this. To begin with, we can just work with JSON data as if we were in JavaScript, which is quite impressive for a compiled language like Rust. Next is parsing. The serde JSON crate has an inbuilt JSON parser, which is called with the from str method. Here I give as template parameter value, such that I parse into generic JSON values. Since I do onWrap here, the variable j will have type value. If I didn't do onWrap, like here, then j would have the result type, result value or error, because obviously parsing JSON can result into an error. I'm lazy here and don't want to to check errors, so therefore I directly unwrap. Another way to specify this template argument is to give the target type here, then this here is derived. And as you can see, I'm going through the same examples as before. Notice the string notation here. I'm using raw strings such that I don't have to quote the quotes. Here I use an R, then an arbitrary number of hash characters and a quote character. And at the end, I just need the same. Why an arbitrary number? Such that I could use multiple or one hash character in here. Anyway, here is parsing. Here it works all. And in the end, I can show you how to actually deal with errors. In this case here, I have actually parsed into a value, but I keep the result in this way. And then I can match on it and can either print an error or I can print OK. Notice that there is a parsing error here, so that when I run this, I will see the error message. Here we see all the things working, except here, expected comma or closing bracket in line 1, column 4. The match expression can also be used to work with JSON objects. Let me here have the same JSON object again, which is an object. Now, and here I have a number or a string. If you want to match on the type, you can just use match and then use the type specifier here. And if it is a number, then this n variable here will automatically be bound to a number, and then you can work with a number. Likewise, in the case of a string, the variable in here due to the pattern matching, will automatically be bound to a normal string in Rust, and you can work with that in here. Here, I, at the same time, access a sub-object, so I take the D attribute, and then in there, at index 1 is a string, and I can match that with a reference. So if that is a reference to a string, then it matches, and I obviously also get a reference to a string here. Let me run this. It works. So this match expression makes working with these untyped JSON values very easy and convenient, and that's basically as good as it would be in JavaScript as well. Finally, let's look into type-safe parsing. Here I have derived serializer and deserializer for a struct type, which is very simple, just the name, age, and hobbies. I have also added hints for serde to rename the next field, this one here, which is called age in the struct, into age in years. And I immediately have code automatically generated for me to serialize and deserialize these types. For example, here I have a person object, and I can just use the toString method on a reference to a person object now, because I have derived serialize and deserialize here. Actually, serialize here. So that here produces a string as or an error. And since I unwrap, because I know that there's no error in serialization, I get back an actual string. So with no additional code, I've automatically implemented serialization for my person object. Likewise, we can see take the parsing function from stir with a reference to a string and can parse it back. Since it knows that the result type here is supposed to be a person, we parse with this information of the deserializer here and create a new person object. I could also have used here the type person to get to the automatically generated code, but it works like this. If you need to handle the errors, then you have to use serde JSON result person here, and then you can parse here, and we will see in an example that here is actually a parse error, namely the attribute here is not called age in years, but just age x. Therefore, it will not be recognized, and we will see the error message. Let's run this. So first of all, we have serialized the object into this here, the compact JSON notation. We have deserialized it back. Notice that in the serialization, it's called age in years, whereas in the object itself, it's called age. And when we try to deserialize the wrong representation, we get a parse error, namely age in years in line 2, column 50 is a missing field, so we are not getting there. Let's look at this again. It's just a few lines of code, adding the serialize, deserialize here, adding it in the cargo toml, and then you have full serialization, deserialization support with proper error handling for your own types. That is really powerful and convenient, and that is one of the reasons I wanted to show you the JSON support here. We have seen JSON support in Rust. I can only reiterate that I find it very, very nice and convenient to work with JSON in Rust. It's very efficient, and I haven't even shown you all the possibilities like different configuration of the serialization and deserialization and so on, serialization, deserialization to other types of data. It's very, very powerful. Have a look at the accompanying web page and the links I provide there, and I hope you enjoyed this and have fun with JSON in Rust yourself.